This is Algebra 2, Lesson 20. We're going to talk about the simplification of radicals and lines parallel to another line. We're going to start on page 98. Simplification of radicals. You remember radicals are just the numbers under a square root or another root sign. So we're going to start with a product of the square roots theorem. If m and n are non-negative real numbers, then the square root of m times the square root of n equals the square root of m times n. And the square root of m times n equals the square root of m times the square root of n. Okay, so let's play with that. We've got the square root of 10, and we can break this down into its prime roots. The prime roots of 10 are 2 and 5. So we can say that the square root of 10 equals the square root of 2 times 5. And this is going to equal the square root of 2 times the square root of 5. If you plug this into a calculator, you're going to get 3.162277. If you plug this into a calculator, you're going to get 3.16227. They equal each other. They're the same thing. Okay? If we have the square root of 2 times 5 times 5, that's going to be the same as the square root of 2 times the square root of 5 times the square root of 5. Okay? So if they're all together, we can break them up. Now the square root of 5 times the square root of 5 is just 5. So this is actually going to come out to 5 times the square root of 2. And we're going to leave it in this form. Don't give me when we're working on these, please do not give me a decimal equivalent. I want to see the square root left there. Okay? Alright, so let's try one. Simplify 3 times the square root of 50 minus 5 times the square root of 200. We can simplify radicals to their prime roots, or we can look for square roots. Either way, we'll get the same answer. So let's start by finding prime roots. So we have 50, and we have 200. Alright, so the the prime roots of 50 are going to be, well, it's 5 and 10, so we have 5, it's a prime number. And the prime roots of 10 are 2 and 5. So we have 2, 5, and 5. Let's see, for 200 we have, it's 5 and 40. And from 40 we've got 5 and 8. And from 8 we can do 2, 2, and 2. So the prime roots of 200 are going to be 5, 5, 2, 2, and 2. So we can rewrite this as, do it down here, 3. The square root of 50 is going to be the square root of 2 times the square root of 5 times the square root of 5 minus 5. The square root of 200 is going to be the square root of 2 times the square root of 2 times the square root of 2 times the square root of 5 times the square root of 5. Okay? The square root of 5 times the square root of 5 equals 5. So that makes 3 times 5 times the square root of 2 minus the square root of 2 times the square root of 2 is 2. So we have 5 times 2. This 2 gets left here. And then the square root of 5 times the square root of 5 is 5 times the square root of 2 that got left there. Okay, so now we can simplify this. 3 times 5 is 15 times the square root of 2 minus 5 times 2 is 10 times 5 is 50 times the square root of 2. 15 times the square root of 2 minus 50 times the square root of 2 is negative 35 times the square root of 2. Okay? Alright, if we had done this with square roots instead of prime roots, that means we're going to start with 50 and with 200, and we're going to find roots that are squares, so we can pull numbers out. So, for example, 50 is 25 times 2, and 25 is the square root of is the square of 5, right? So if we say, let's see, let's do this one too. 200 is 100 times 2, and 100 is the square of 10. So we can say, in place of the square root of 50, we can say 3 times the square root of 25 times the square root of 2 minus 5 times the square root of 102. Sorry, I'm writing too small again. The square root of 25 is 5. So we have 3 times 5 times the square root of 2 minus 5. The square root of 100 is 10 times the square root of 2. And now we can simplify. 15. 3 times 5 is 15 times the square root of 2 minus 5 times 10 is 50 times the square root of 2. And now we're back to 15 times the square root of 2 minus minus 50 times the square root of 2 is negative 35 times the square root of 2. Okay? We get the same answer either way. If you can think in terms of squares, this is a little faster because you don't have to do all of this. If it's easier for you to find prime roots, do this way. Okay? You're going to get the same answer either way, so do the way that's easiest for you. Let's try some more. Okay, simplify. 3 times the square root of 2 times 4 times the square root of 12 times 2 times the square root of 3. Okay, let's start by rewriting this and putting the whole numbers together and the radicals together. So we have 3 times 4 times 2 times the square root of 2 times the square root of 12 times the square root of 3. Okay, 3 times 4 times 2 is 24. 2 times 12 is 24 times 3 is 72. Okay, we have 24 times the square root of 72. So now we need to find either prime roots or square roots of 72. So 72 is 9 times 8. And 9 is a square. It's 3 times 3. 8 is not a square, but we know it's actually 2 times 2 times 2. Okay? So we can say that 24 is the square root of 9 times the square root of 2 times 2 times 2. Okay? Because that's 8. The square root of 9 is 3, so now we have 24 times 3. 2 times 2 is 4, and the square root of 4 is 2. So we can pull one of those 2's out, and that leaves us with the square root of 2. 24 times 3 is 72, times 2 is 144, and we still have the square root of 2. So that's our answer. Okay? Let's try another one. We have 4 times the square root of 3 times the quantity 2 times the square root of 3 minus the square root of 6. Okay, so we're going to use the distributive property. We have 4 times 2 is 8. The square root of 3 times the square root of 3 is 3. Minus, don't lose that minus, 4 times 1, there's an implied 1 here, times the square root of 3 times the square root of 6, which is the square root of 18. Okay? 8 times 3 is 24. Might as well get that done with. Minus, we have 4. Let's see. 18 is 9 times 2, and 9 is a square. So we can say it's the square root of 9, which is 3, times the square root of 2. Don't lose that square root of 2. So now we have 24 minus 12 times the square root of 2. And that's it. There's nothing else you can do with that. So don't lose that square root of 2. We can't simplify this further. Okay? Okay, that's it for those for the moment. Let's look at parallel lines. Parallel lines share the same slope, but they have different y-intercepts. So if we look at the equations, y equals 1/2 x plus 2, y equals 1/2 x minus 1, and y equals 1/2 x minus 4, we'll see that all three of these lines have the same slope, but they have different y-intercepts. Okay? So I graphed all three of these lines. This is y equals 1/2 x plus 2. And you see the intercept is at x equals 0 and y equals 2. This is y equals 1/2 x minus 1. And you see the intercept is at x equals 0 and y equals -1. Here is y equals 1/2 x minus 4. And you see the intercept is at x equals 0 and y equals -4. But they're moving, as x is increasing, the y is increasing at the same rate. So the lines are parallel. We can use this to find equations of lines that are parallel to other lines. So, here's our example. Find the equation of a line that is parallel to the line 2y minus x equals 2 and passes through the point 3 and -1. So we're going to start by writing this formula, this equation, into the slope y-intercept format. So we have 2y minus x equals 2. Let's move this x over. And we have 2y equals x plus 2. Divide all the terms by 2, and we get y equals 1/2 x plus 1. Okay? Okay, this is the equation of the original line. We need to find the equation of a line that's parallel to it. So we know it's going to have the same slope, so the format of the equation is going to be y equals 1/2 x plus b, and now we need to find b. And we're going to use the point that they gave us. This line is going to pass through x equals 3 and y equals -1. So we're going to substitute those values into x and y and then solve for b. So -1 equals 1/2 times 3 plus b. -1 equals 3/2 plus b minus 3/2 minus 3/2. This is 2/2, this is 3/2, this is -5/2 equals b. Okay, if -5/2 equals b, then the equation of our line is y equals, the slope is 1/2 x minus 5/2. Okay? And that is it. Try the practice problems. Do your homework. Let me know if you have any questions. Thank you.